So let's look at some non-carbon groups, non-carbon functional groups. Because although we're going to be partial to carbon in this course, we're going to see a lot of functional groups that do not contain carbon. So the first we'll hit are the halides. Now the halides include that second to last column on the right of the periodic table, atoms like fluorine, chlorine, bromine, and iodine. Sometimes people will want to refer to halides in general without picking out a specific halide. They'll just write X. So these are halide groups on a larger molecule or on an alkyl group. So you might have RCl, and this would mean, oh, there's some kind of hydrocarbon group attached to my chlorine. And we don't have to put it in, but just to be clear that chlorine satisfies the octet rule and has 3 lone pairs. So what are some examples? This would be a 2-carbon alkyl group. This would be an alkyl fluoride. Specifically, that's an ethyl group. And then, of course, you can, that's a methyl bromide. So the halogen represents a functional group in that structure. Halides are fairly common. Next, we'll go with alcohols, which we've bumped into before. Alcohols are where we have an OH group coming off the rest of this molecule. So there are a lot of simple alcohols having an alkyl group off the OH. This alkyl group specifically is methyl. So this is methyl alcohol. You can also call it methanol. But an alcohol is an OH group. Remember, when you write OH groups, it's important to be clear on the connectivity. If you're going to write it from the other side, we need to swap the OH so that the oxygen is clearly connected to that carbon. Okay, next we'll talk about ethers. Ethers have not just one hydrocarbon group coming off of an oxygen, but actually have 2 hydrocarbon groups coming off that oxygen. And those 2 hydrocarbon groups do not have to be the same thing. And to show that they can be different, we'll say one is R and the other is what we call R prime. And so they can be different. Let's see an example of that. We could have on one side, we could have a small 1-carbon group. On the other side, we could have a 2-carbon group. So we have 2 different hydrocarbon groups. This would be R, and that would be R prime, or we could call this R prime and that's R, and vice versa. Of course, they can be bigger than this. Here you have an oxygen attached to 2 carbons. One is an alkyl group. This is an alkynyl group. 2 different R groups attached to an oxygen. So that gives us ethers. And finally, we'll hit the amines. Amines are where you have an R group coming off of a nitrogen. Now, nitrogen can form potentially 3 bonds. I'll put the lone pair to be explicit. We can always add lone pairs up here on these oxygens. So you can actually put more than one R group on the nitrogen. So this would be an amine. That is an amine with 2 R groups, and they can be the same or different. And surprise, we can put 3 R groups on there. Now we'll call this, to distinguish the third one, we'll call it R double prime. And so these are all considered amines. And these R groups, it could be methyl, it could be ethyl, or other hydrocarbons, alkynyl groups, you name it. So there's a lot of flexibility, but these are common types of functional groups that we will encounter in our organic molecules in organic chemistry.